In this lesson, you will learn to solve quadratics by completing the square. This method of solving works best for problems in standard form only if a equals a 1 and b is an even number. You can solve equations if b is an odd number. However, it's easiest if b is an even. But you definitely have to have a equaling a 1. I am not showing you the method with a being greater than 1. If the equations are in vertex form, you cannot use this completing the square method. Completing the square changes equations from standard form to vertex form. So we're actually going to first look at that before we actually start solving. So in order to change from standard form to vertex form, here our first example is in standard form. So you'll start by setting it up with a plus a blank and a minus a blank. So just rewriting your problem, plus a blank, minus a blank, moving the given C value kind of out of the way so we can come up with our own C value that makes this a perfect square trinomial. Well, we start with our B value, which is 10. In order to solve for our C value, we use this formula. We take half of the B and then square it. So 10 divided by 2 and then square that. Be sure to show each step of this work because 10 divided by 2 is 5, and we actually need this number later in our work. So 5 squared is 25. That is the number that goes in each of our blanks. So again, we've taken our original problem, we moved our C value out of the way, just scooted it over so we could have a plus a blank and a minus a blank. Make sure you have a plus and a minus or else it will not be set up correctly. So our next step, we need to write it in vertex form. The first three terms, this x squared, 10x, and 25, they are now a perfect square trinomial and they can be factored. We can use the shortcut of just taking half of the b, which is what we did earlier. So we keep our y equals, again, these first three terms become half of the b was a 5 squared. So we just have x plus 5, that whole quantity squared. Of course, if there's a positive or negative b, your factor will reflect that. The last two terms are combined. You always just combine those together. So this is a 12. You're going to take away 25. So 12 minus 25. That gives us a negative 13. So when you combine those, you can say plus a negative or just minus 13. So that is our equation in vertex form. We can now name the vertex. If this is vertex form, in order to name the vertex, we look at this h value and we do opposite. So that would be a negative 5, comma, we look at our k value and use the exact value. So negative 13. Opposite and exact for naming that vertex. Let's look at another example. Again, we have our original problem given to us in standard form. We'll set our problem up with a plus a blank and a minus a blank, just moving that original C value out of the way so we can add our own C value that's going to make this a perfect square. We do that by taking our B value, being careful this one is a negative. You see the reminder to the side, pay attention to your sign. It's very important to solve these correctly. So our C value, we will take and divide our B by 2 and square it to find that new C value. Well, negative 18 divided by 2 is negative 9, making sure that we show that number because we'll need it later in our work. Negative 9 squared is a positive 81. So that is the number that goes in our plus and our minus blank from taking half of the b and squaring it. That's the number that fills in the blank. So now we're going to write our problem in vertex form. So y equals. Remember these first three things, they're factorable, but we're using a factoring shortcut. Y minus 9, because that was our half of b. Then we combine the last two numbers. So negative 6 minus 81. Yes, making sure again that we're careful with our signs. Negative 6 minus 81 is negative 87. In order to name our vertex, we use opposite and exact. So positive 9, comma, negative 87. We can check that in the calculator using our table. So let's do that real quick with this second example. If you press y equals and type your equation that's in standard form, so x squared minus, I just realized that's supposed to be minus 18x minus 6. That's our standard form. Let's go ahead and type the vertex form in as well for y2. X minus 9, quantity squared, minus 87. First of all, we want to see that these are truly equal to one another. So if you go second table, we first notice in the y1 and the y2 column, no matter how much you scroll up and down, those values do match. So that's a way you can know that your standard form and your vertex form are equivalent with this complete the square method. When we say that our vertex is at 9, comma, negative 87. So when we scroll to that positive 9 in our x column, we're feeling pretty good because we see the negative 87 in our y column. But we also want to look out for that repetition. If this is truly our vertex on either side of that negative 87, we should see a repetition of the y values. And we do see that in order to make this our vertex. Let's now look at some solving. So those first examples were just a reminder of completing the square. These next examples we will now actually continue by solving. Well, first things first, we need our problems in standard form. A lot like just completing the square, it has to have the a, b, and c terms all on the same side. So we need to do that first by getting the equation set equal to 0. I typically recommend keeping your ax squared term positive. If you can, it just makes life so much easier, especially with this method of completing the square. You have to have a positive 1. So that means we're going to add 8x to both sides. Because we need it in standard form, of course, that equals 0. Our ax squared will go first, then our bx term, and then finally our c, putting those in the correct order. Since we couldn't really combine any like terms, we were just writing them in the ABC order that they are supposed to be in. Well, now we're ready to set up our blanks. So x squared plus 8x, the first two terms we just keep. We're ready for our plus a blank, then our minus 20, and then our minus a blank. So you just set up a plus a blank and a minus blank, moving that c value that you originally had, moving it kind of out of the way so we can find a new c value that completes the square. We do that by taking our b value, which is 8. You'll take that 8 and divide it by 2 and square it to find your new c value. So 8 divided by 2 is 4, and 4 squared is 16. And really, I always recommend keeping that in parentheses. It doesn't really matter for this problem because it's positive, but definitely get in the habit of always put parentheses because you have to have it when it's negative. So that is the number that goes in the plus a blank and a minus a blank. And some students just put it right back in to that problem, but I'm going to write it down on this next line just so we can keep the flow of our work in order. But feel free to put that 16 in those blanks that you already have set up for that plus a blank and minus a blank for completing the square. So we're now ready to write our vertex form. Again, keeping that 0, just bringing it down each time. Now that we had it in standard form from the beginning, we just brought it down. The first three terms become one quantity squared, and we use our half a b number, so x plus 4. The last two terms, we combine those together. Negative 20 minus 16 gives us negative 36. So now's a great time to stop and check your work if you would like. You could take that standard form and vertex form and check them in the calculator to make sure those y columns check and match up before moving on. But we do need to move on and actually finish solving. So in order to solve, we do undo the order operations. If you have any grouping, exponents, multiplication, division, or adding or subtracting. Once you do the process of completing the square, we can just undo the operations to solve this equation. So we actually will start with adding 36. So we get 36 equals, bringing down the x plus 4 quantity squared. That took care of the adding and subtracting. We don't have any multiplication or division, so we just move on to the next operation, which is the exponent. We'll need to take the plus or minus square root, always remembering that plus or minus sign. By taking the square root, it gets rid of that exponent squared. So plus or minus 6 equals x plus 4. And if it's bothering you that the equation is set up in this way, feel free to flip it around and write x plus 4 equals plus or minus 6. And actually, I'm going to do that in our next step because I like to have x plus 4 first and then my values. So negative 6 and x plus 4 equals positive 6. Because this says that it equals both of those numbers, in order to do our last step of undoing what was in the grouping, we need to write our two equations. Let's solve that by subtracting 4. So our first solution, we get x equals negative 10. And again, subtracting 4 for our second equation, we get x equals 2. So our solutions in set notation, we get negative 10 and positive 2. You can actually check the solution all the way back to the beginning. If we say our solutions are negative 10 and positive 2, there's a couple different ways, but I really think the best way to check is just substituting it back into the problem. So negative 8 times negative 10, that should equal negative 10 squared minus 20. So they do equal. We also need to check the other solution, the 2. So negative 8 times 2, that should equal the 2 squared minus 20. And again, that does check out. So we know that both of these are true solutions. There are ways to also check it with the table. So if you are interested in that, please ask me to show you checking it with the graphing calculator using the table. Let's look at one more example of solving. Well, we first have to start with getting in standard form. We notice there are 3 terms here on the left, however, they're not even in the correct order for A, B, and C. We also see that it's set equal to negative 12, and in order to call it standard form, it has to be set equal to 0. So we will begin by adding 12 to both sides. That will help us get it set equal to 0 by canceling those out. And then also while we do that, we'll combine it with its like term of the negative 52. In this step, feel free to write these terms in the correct order. I'm just going to go ahead and bring them down for now, and then we'll order them correctly. Negative 52 plus 12 gives us negative 40. And that does equal our 0. So let's put these in the correct order. And me personally, I like to have my 0 on the left when I'm completing the square. So let's start with 0 equals our ax squared term will be that 1x squared. Our bx term is the negative 6x. And then finally the c, the negative 40. So that is our equation in standard form. We're now able to complete the square. Let's write it with our plus and minus blanks. Plus a blank, and minus a blank. In order to fill in those blanks, we need to find our b and divide that by 2 and square it. So in this problem, here at standard form, be very careful that you don't do it up in the original problem. Remember, in order to truly name your a, b, and c, it has to be in standard form. So our b value equals -6. In order to solve for our c, we take half of that, divide it by 2, and square it. So -6 divided by 2 is -3, and when you square that, you get +9. I hope you've noticed by now that when you square a number, it should always equal a positive. So the number that goes in the plus a blank and minus a blank should always be positive. Go back and check your work if it's not. So now we take and factor the first 3 terms with our shortcut. So 1 parentheses squared using that half a b number, so x minus 3. And then we combine the -40 minus 9 gives us -49. When you solve, you're ready to undo the operations. So let's look and see what we have. Grouping, exponents, multiplication, division, adding and subtracting. Well, in this problem, we see that x is in that grouping symbol. We also have an exponent. We don't have any multiplication or division, so we'll be able to skip over that, but we do have some subtraction, meaning we will need to start with adding. Add 49 on both sides. 49 equals x minus 3 quantity squared. So that step of adding and subtracting, we have done that correctly, and we're ready to move to the next thing. Like we said, we can move over the multiplication or division because we had none. We're ready to undo the exponent. So that means we're going to take the square root, remembering our plus or minus sign. So we get plus or minus 7. Squaring and square root, those cancels, leaving us with just the x minus 3. So that step of our work is done, and we're ready to undo what was in the grouping. We have this positive and -7, so we want to say x minus 3 equals both of those numbers, so -7 and x minus 3 equals the +7. Again, I want to stress that if the plus or minus is with the 7, that's what you keep it with when you write your 2 equations. Be careful. This is x minus 3. Don't write it as x plus 3 and x minus 3, giving the plus or minus to the wrong number. Let's add 3 to both sides. So we get x equals -4. And again, adding 3 on the second equation, we get x equals 10. So our solution, if we write in set notation from least to greatest, we get 4 and 10. Here's a side note to know, what are we finding when we find these solutions? The solutions of a quadratics mean that they are the zeros or x-intercepts. So zeros or x-intercepts. And that's why it was so important from the very beginning to get our equation set equal to 0, because that's what we are finding. So they are the zeros or x-intercepts of the quadratic function when it's graphed. So if I was to graph this problem, it would cross at those numbers on the x-axis. It's finding those x values where it crosses our x-axis.